Struth, would ya look at that mushroom? Shining like a brand new esky at the servo. Fair dinkum, if it's red with polka dots it's gotta be gourmet, yeah? I mean, I'm no drongo. I've eaten lichen off a glacier and lived to tell the tale. She'll be right. Oh, crikey, I've gone proper troppo. The rocks are doing the hokey pokey, and that seagull's just called me mate. No worries though, Loomy, keep it together. Flat out like a lizard drinking, but together. Hang on, what's that floating past me eyeballs? A gear? A bloody massive 36-tooth gear? Well, I'll be stuffed. That's a thing of beauty. Symmetrical as a rot nest sunset and twice as smug. Each tooth is winking at me like, go on then, champ, make us. Bloody oath I will. Honestly, how hard can it be? 36 teeth. Count 'em like carrots in a feed bin. I've got hooves, but they're basically precision instruments if you squint and believe in yourself. This is engineering, not rocket surgery. Any old sand groper could knock this up between Smoko and Arvo. I'll just trot into the workshop. Steady now, don't stack it. If anyone asks why a pony's running a lathe, I'll tell it's a community art project. Very Fremantle, very edgy. No one questions that stuff. If this gear doesn't work, I'll just say it's artisan. Slap a price tag on it and call it rustic. Eat a fancy mushroom, see a gear, build a dream. That's living made. Now, anyone else reckon the workbench is singing Waltzing Matilda, or is that just me?
Hello! Well, in this episode of Finno Creek Machining, we are going to make a 36 teeth gear. Yeah. Well, yeah. One bit of a warning and a disclaimer here. Never ever eat fly agaric. It has some psychoactive properties, but it is poisonous. It's not like deadly poisonous, but poisonous enough to make you really, really ill. And in most cases hospitalized. Yeah, so never ever eat that one. It's toxic mushroom. It's beautiful, but it's toxic. So that's about mushrooms. And yeah, so we are going to make 36 teeth gear. Well, my lathe does not want to thread with the normal M12 thread with a gear set that is normally inside there. I need to change two of those so that it can do that. Actually, the gear that I would need would be 72 teeth gear. And this I already have ordered, but it will come maybe on January, some beautiful day. So it doesn't have the time to come into this video. So what we will do, we will make a 36 teeth gear. Why I didn't make the 72 teeth gear is that I don't have the material. It requires something like well over 10 centimeters in diameter piece of flat metal, I didn't have that. So now, and also it's very funny because if you order that material, it is more expensive with the postage and everything than readily made gear from China. And this is something like, I don't know what to say about this. It's cheaper to get readily made gear than order the material and then make one. Okay. But I had material for the smaller version, which also works. So just you know the scales inside the lathe, you have to choose half the pitch. So then you are all right. So so where would we start? Okay, let's make the blank first, and then set up the milling machine, mill the thread, the teeth, and after that we have to do some cleanup for this gear, and then there we are. But first we have to create the blank for that one. Let's start with that one. Well, this part here is the blank for my gear. It will become a 32 teeth module 1.5 gear, and the outer diameter should be finally 57 millimeters. And I'm taking 2 millimeters per pass from the diameter and feeding quite aggressively, and this is because well, I want to do the chip control. So first it produced very long stringy chips which are not very good, and now it's producing very nice, very small C-shaped curved chips, which is good. And so, yeah. So this is jig I have made, mandrel, so that, well, this piece is too thick actually. At the moment I need to make it a little bit thinner, and also make the corners right. As you can see, it produces this horrific burr around there, and yeah. And well, but this is just a roughing phase, so 2 millimeters one more time, and there we go. Let's measure it. I think it's still far from the truth, but yeah, it's 65. So, well, it's not too far away. 57, 65. It's less than 10 millimeters. Okay. Then we go again. Well, let's see. Let them be there. Yeah, okay. Now you will see how it does. With this it will be probably a better surface finish, but it will be really bad chips. As you can see, they are really bad. Well, not that bad, but they are like a meter long. Okay, and let's take these away. Oh man. Take it out. I don't want to scratch it. Although the finish, oh, it's smooth, really smooth, but it's just not shiny. All I really want to do here is to clean this back surface. Now it's touching. I think it's cleaning it quite okay. Was it enough? Yeah, okay. That's okay now. And then the other side. Now I will present you the setup for milling, well, 32 teeth spur gear. And yeah, so the first thing is the cutter. What cutter should we be using? Because the cutters come in sets of 8 like this. Okay, and I have here a book. Hopefully you can see my little table here. The table says that for 32 teeth gear it should be cutter number 5. Okay, let's take cutter number 5. So 1, 2, 3, 4, 5. That should be 5. Yes, there is a number 5 stamped on it. Very good. These rest we don't need anymore. Just this one. And then let's put it there. the direction of rotation is really critical in this case, because if you put this wrong way around, it will loosen the cutter. It just does not work. This way it will be tightened. You don't need to tighten it very tight originally, it will tighten itself. Next is the division head setup. First of all, I have dialed this in. It's there quite accurately. And I will now choose the correct disc for this one. And I have here 20 holes on the outermost circle. That's 20 holes. And now if we calculate this one, so 20 times 40. Why 20 times 40? This is because it will be like 40 rounds for each turn for that one, and then you multiply that by the number of holes. So the total number of holes for the whole rotation is in this case 800. And if we divide that by 32, so we get 25. So that's good. Okay, so let's put it there. Now this is, first I need to put this here. Then I have 3 screws here. Okay. Now it's done. So every time I change, let's assume I start here. So when I want to change to the next teeth, I do 25. So this is one total round and then 5 more there. And after that I will move it like that and lock my thing, and everything is honky-dory. So, but I always start from the 0. This is, let's see which way the backslash is. Yeah, that way. Okay, dividing heads always have backslash. And that has to be, you need to take care of that all the time. Yeah, okay. So now this is done. This needs to be put on the center line. Well, approximately to the center line. So let's see. Okay, and one way to do this is to put there something like this behind there. And then see that it now we need to raise it a little bit more. It's still tilted more, still tilted more, it's still tilted a little bit more even. Well, it's still a little bit, just a little here. Well, there you are. No. Let's see if I can. Okay, there you are. That's the one. The next step would be to touch it. There you go. And now, let's see, I have 110. Let's see how it looks like. Well, it's okay. And now touching this, I need my glasses. Oh, you can hear this one. There you are. There it is. Okay. And now, what is the depth of cut here? Well, that's a good question, isn't it? Fortunately, we have this information in this same book. There we have a measurement of the whole teeth the whole height of the tooth. Das heißt in Deutsch Zahnhöhe. Und this is 2.166 millimeters for module 1. So I have to multiply that one with module. So 2.166 times 1.5 equals 3.25. 3.25. Okay. Maybe I remember it. 3.25. So I have already zeroed my y here. So 3 point. So it is 1, 2, and 3.20 and 5. Yeah. And then I log my y. There you are. That's it. Now it's just to mill the teeth. But again, we need some lubrication there, cutting something, and I'm using cutting paste like this RTD. This is something and it's nasty stuff. So what I will do now, I will try to put it there, not deliberately, just so that it is there. Okay, I think we are now around the table. That's our 0 point, and this is really tough, so to say. There was the brake on. It actually makes the case. So let's take the backslash away, put the brake on. Yeah, and this I will feed manually. And it's 110 revolutions per minute. Let's see. It actually has no trouble at all with this one. Okay. That's it. First hole done. Hole. Now I want to mark my 0 here so that I'm near enough. So let's put it on 10. Okay, now next. So 1 full turn and then 5 more. There you are. And then put this there and lock it. Then we go again. And this is repeated 32 times. And I really hope it creates a good teeth for us. And yeah, why I'm milling it from that side, not in the front. This is because I don't want to put the pressure on this tailstock here. I will put the pressure into this dividing head. It has a very stiff bearings there. I know because I have opened and cleaned it up. And let's see how these teeth now look here. There is one teeth already. And it looks exactly as it should. Huh. Wow. So Well, it's just to do this. Well, this is now the last gap between teeth. And this is the place where you make or break. So if you have done everything correctly, this should now form a really nice gap there between the teeth. So let's see. This is the last gap. There you are. Let's see how it looks like. Well, not too shabby. Yeah. Okay, one way to test this, now when we have done all the teeth, is to go to the first teeth and see how it does. Like this. Nothing should happen now. Absolutely nothing. Let's see. This reveals if the workpiece has moved or something. Yeah, it doesn't cut. Well, very slight cutting, well, maybe chips there or something. But yeah, that's it. it's done. Yeah, okay. Next step, there is a horrific burr in this one. And I should get rid of that. Well, that's something. Yeah, let's see. That will be the next step. And I will do this in, I will use a wire brush in my drill press. Something like this tool rescue, who is always brushing his components in this drill press with a wire brush. I will now do this that same way. Now, this is the wire brush, and here is the workpiece, and these are the safety goggles. Very essential here, and this runs quite fast. Well, these need to be taken away with some other method. Yeah, that's it. It's not clean as a whistle, but very, very much better. Yeah. Okay. Yeah. Oh. So now I will try to face this extra away from here. I have dialed in this gear into my 4-jaw independent jaw chuck, and it's straight and it's well centered. So yeah, and well, let's see about the speed. It's about right. Yeah. So now let's touch it first. Okay. A little bit more speed.
Well, somewhere at this point I realized that I had made a huge mistake. Namely, 32 is not 36. This was supposed to be a 36 teeth gear, and now I had made a 32 teeth gear. And furthermore, the diameter is for 36 teeth gear, and yet I have milled 32 teeth into this one, so the teeth have incorrect geometry, and this workpiece is crap.
Copper as well. I think we can assume it's a very good one, but oh, I almost forgot. We need to do one thing before I get it away from the chuck. like that. Wow. Well, almost ready. It just needs a group or gear, key. Keyway. What is this? The key thing. Key thing. Okay. So here we are. A little bit of de-burring with the file, and we should be ready to go with this one. Well, I made 2 gears, actually. First of all, this one, which is like this, and then another one, which is like this. Well, this is a gear that is incorrect. It has wrong teeth geometry. This one is correct, and it also has the key slot here. So yeah, and this one has 36 teeth. This 32 teeth that have a correct, incorrect geometry. This was a learning thing for me as well. So this is aluminium, and I will try to use this one first, but I will receive at some point next year, which is pretty soon, I will receive the correct gear. But also that one needs some work in order to get it correct. So, about this project here. My intention was originally to make it possible for my lathe to thread M8 and M12 threads, the standard ones. And now I have the possibility, but let's see. I will actually do some threading in the next episode using my retracting tool holder. Hopefully it works. I have not used it yet, and it will be in real action in the next episode. So now it's time to say goodbye till the next time. Bye!